Choosing the correct nipples to use is a little bit more complicated than most people understand. It's important to use the right nipple for the wheel that you're building. We will look at wheels that use regular nipples and then wheels that use internal nipples, and we'll start with wheels that use regular nipples. Here's a picture of a standard nipple and a plain ordinary spoke. These are two Supreme nipples. Notice that the part of the nipple right under the head of it is sort of rounded or bowl-shaped, and this allows the nipple to orient nicely in the rim, and is called for that reason polyaxial. These are those same two nipples together with a cross-section of them, which you can do if you take a nipple and you grind off half of it on a bench grinder. Then you see the nice brass part with the threads inside exposed. Here are those two Supreme nipples. The one on the left is a 14 millimeter nipple. The one on the right is a 12 millimeter. And sometimes the 14 is called 9/16 of an inch, and sometimes the 12 millimeter is called a ½ inch. We're going to look closely at some dimensions of these two nipples. That distance right there for both nipples is 9.4 millimeters of fully threaded nipple. And at the top of each one is about 1.2 millimeters of half thread. Now the nipple on the right has at the bottom of it 1.4 millimeters of unthreaded bore, and the one on the left has 3.4 millimeters of non-threaded bore. So both of these nipples are exactly the same except for the length of the unthreaded bore at the end. Which means that in comparing these two nipples, the correct spoke length is unrelated to the nipple length. Using a longer nipple does not mean that you can use a shorter spoke. In both cases, the nipples will not screw down much beyond the point shown there past the threaded portion of the spoke. So the nipple pointed to here will not screw down any farther. The nipple on the left is the same size as the nipple in the middle, just seen in cross-section, and you can see that trying to go any farther with the nipples, you run out of thread. So that means if the spokes are still loose at that point, then the spokes are just too long. And using a shorter nipple will not help either, because the thread location is exactly the same. So we ask this question, what determines the length of the nipple I need? And the answer is, it's the depth of the rim spoke bed that the nipple has to go through, because the wrench flats on the nipple must extend far enough through the rim that they are accessible. Here is a rim with a thin spoke bed. Those lines there represent the thickness of the spoke bed, and you can see that if I use either a 12 millimeter or a 14 millimeter nipple, the nipple will easily extend far enough through the rim's spoke bed that the wrench flats will be accessible to me. Here I'm looking at both of my nipples. There's my 12 millimeter nipple on the left, and there's my 14 millimeter nipple on the right. That amount of the nipple sticking through the rim is quite adequate. I don't need that additional length over there. Either of these nipples will work because the wrench flats are fully exposed in both cases. Since in both cases I have no difficulty getting my spoke wrench on the exposed wrench flats, I'm going to pick the shorter nipple of the two, but I could use the 14 millimeter nipple if I didn't have any shorter ones. Here we see a carbon rim that has a thicker spoke bed. There's the spoke bed there. It's about 4.3 millimeters, and then you can see if I use my 12 millimeter nipple, the wrench flats are a little too short. The nipple doesn't quite come through the rim far enough. So I'm better off using my 14 millimeter nipple, which gives me a larger exposure of the wrench flats. So that's the one I'm going to use with that larger, thicker spoke bed. In this picture here, you can see that the 12 millimeter nipple on the left is a little short, and the 14 millimeter nipple comes through better with more exposed wrench flats. Occasionally you'll run into a rim that has a very thick spoke bed. It'll probably be a wooden rim, and here's a short piece of a wooden rim in cross section. That is actually the thickness of the spoke bed that the nipple has to stick through and still have some wrench flats exposed on the inside. This is a tubular rim, and the nipple is recessed into the rim so that the nipple actually is going to look kind of like this, with a little bit of the nipple sticking out the other side. This is actually a Supreme 25 millimeter or about 1 inch nipple, and that amount there is what actually protrudes. Here we see a little depiction of what that nipple actually looks like. There on the right there's a spoke, and I've taken one of those 25 millimeter Supreme nipples and ground off half of it on a bench grinder so that you can see it in cross section next to the actual appearance of the nipple. And if you look at the threads, we see that we have about 10 millimeters of threaded part of the nipple, and then before that a really long 15 millimeter bore. And this little part of the nipple right here, of course, is what has to extend through the wooden rim so I have a place to put my spoke wrench. Now let's look at some wheels with internal nipples. Here's a section of rim that uses internal nipples. The hole here is just big enough for the spoke, but not the nipple. The nipple will be attached to the end of the spoke as shown there. Notice the hexagonal shape of that particular internal nipple. These are some of the internal nipples that are in my collection. There's the hex one, and then there are 3 other kinds of brass internal nipples, also known as inverted nipples. Some of these also come in aluminum. If we look in cross section, you can see the spoke coming from the right, going through the rim, and you see that the spoke is screwed all the way to the end of the internal nipple, and that's important. The spoke must extend to the very end of the nipple, or maybe even a hair beyond it. If I take a standard nipple and an inverted nipple that would be used as an internal nipple and put them down side by side, they look kind of the same, but they're not. For one thing, one has a slot and the other does not. Now, if I have a rim that uses internal nipples, I can't just take a standard nipple and turn it upside down. You see on the left there a standard nipple and the cross section of it. The problem is that the slot will dig into and damage the inside of the spoke bed, and the other point is that the flat top of the nipple will restrict its orientation in the spoke bed. You need something that's more rounded to work better. The inverted nipple on the right is going to work much better. Once again, we see the inverted nipple and the same nipple in cross section. The benefit of this is that there is no slot to dig into the rim, and there's a curvature, a slight curvature of the nipple that allows it to seat itself naturally into the spoke bed. Notice also the location of the bore and the threads. The nipple on the left, the standard nipple, when I turn it upside down, I have the threads first, the first thing that the spoke goes into, and then a bore on the end of it, whereas the inverted nipple is properly positioned so that the spoke goes initially into the bored end and then runs all the way to the other threaded end of the nipple. Here's another picture. The standard nipple on the left is intended that the spoke will be inserted through the bore first, and therefore turning it upside down and try to use it as an internal nipple doesn't work, whereas the proper internal nipple allows the spoke to be inserted first into the bore. Some of the inverted nipples that I particularly like come from Supreme in Antwerp, Belgium. This is one of them here, and we see this is quite different from a normal nipple, which has a slot here and no slot on the inverted nipple. The location, once again, of the unthreaded bore on the normal nipple compared to the threaded portion is reversed, whereas it's in the correct position for the inverted nipple, where the spoke goes first into the unthreaded bore and then extends all the way to through the threaded portion of the nipple. And just in case you're interested, here are some nipples that I cut into cross sections, so if you can see perhaps that the locations of the bore and the threaded portion of those nipples. Now it's important that the nipples fit down against the spoke bed. Let's look at some examples. And look at these two here. Notice that this nipple and this nipple here are flush against the spoke bed. This one is a problem though, because the nipple is too wide to fit down inside that very narrow spoke bed. And you can see here there's a gap. That's the purpose of this nipple here. This nipple was invented by a friend of mine, Dieter van Moor of Supreme in Belgium, shown there in a picture with me. And that little nipple will fit right down flush against that rim there where the spoke bed is narrow. Dieter is one smart dude when it comes to wheel building. We're going to make a little table here and compare aluminum or nickel plated brass nipples according to some properties of them. And we'll start by looking at which ones are the lightest. Here we're showing some pictures of weighing 32 nipples. On the left are 32 12 millimeter aluminum nipples, 10 grams. In the middle, 32 12 millimeter brass nipples, 30 grams. And on the right, 32 14 millimeter brass nipples, 34 grams. So aluminum has an advantage in being lightweight. What about color choices? With aluminum, I have lots of cool colors I can choose, in addition to silver and black. With brass, I have silver and black. So score another advantage for aluminum nipples when it comes to color choices. Let's look next at durability. Aluminum nipples are easy to misshape. The metal is soft and they can be easily rounded out, so you can easily get misshapen wrench flats and cracked nipples. Another problem with aluminum nipples is sometimes you'll see this white powder here. This white powder is aluminum oxide, and it develops with aluminum nipples eventually. And the problem is that in addition to the misshaping wrench flats and the possibility of nipples cracking that I mentioned a minute ago, you also have the possibility of the nipple, because of the oxidation, becoming basically frozen to the spoke, which makes it impossible to true the wheel. Because those aluminum nipples can easily become misshapen, it's a good idea to use a four-sided spoke wrench at higher tension. But even still, if the nipple and the spoke become frozen together, then you can't true the wheel, and you're looking at a rebuild. One of the advantages of brass nipples is that they will not freeze to the spokes. So I think we have to give brass nipples the check here when it comes to durability. But let's keep weight in perspective. So we're going to build two wheels, and the front is going to be 20 spokes, the rear 24. So I have a total of 44 nipples. If I use aluminum nipples, I'm going to have 14 grams of aluminum nipples, and if I use brass, I'll have 41 grams of brass nipples. The difference is 27 grams. So how much is 27 grams? Well, here's a pair of sunglasses that weigh 28 grams, and here is a third of a Cliff Bar, which represents about 2 bites, and that's 27 grams. On balance, I tend to favor brass nipples simply because of the overwhelming advantage when it comes to durability and the problem avoidance that goes with that. I made reference a minute ago to spoke wrenches. This Park Tool black spoke wrench is a 3-sided spoke wrench because the wrench flats are grabbed on those 3 sides. This is the Park Tool SW20 Master Mechanic spoke wrench. This is the black version. This is the one you want to use when you get up to high tension. This is a 4-sided spoke wrench. You have these same 3 sides as before, but you have these little nubs that stick in also and grip the nipple on the 4th side. This only slides onto the nipple from above, and it provides a superior grip of the nipple, prevents it from slipping off the nipple accidentally, and ensures that you won't round off any of the wrench flats of the nipple.